In graph 11.6 we've basically shown how to derive a labor demand curve, which we'll now do explicitly here. We begin with the marginal revenue product of labor curve that tells us the additional revenue we'll receive by hiring additional hours of labor. We begin with a wage W star, which will turn out to be our break-even wage, as we'll see in a moment. For worker hours where the marginal revenue product is below the wage W star, we would therefore lose money as we hire additional workers. When marginal revenue product lies above W star, on the other hand, we make money for each worker hour that we hire. We've set our initial W star so that the negative magenta area is exactly equal to the green positive area, and therefore W star represents the wage at which the amount that we lose on the initial workers that we hire is exactly made up by the amount that we gain for the next workers that we hire. Thus, W star is our break-even wage, or our zero profit wage. If wage falls above the break-even wage, we would make a negative profit by hiring workers and therefore would choose not to hire any. If wage falls below the break-even wage, on the other hand, we would make a positive profit by hiring workers and producing, and we would therefore hire workers along the marginal revenue product of labor curve. The labor demand curve is then equal to a segment on the vertical axis above the break-even wage and the marginal revenue product of labor curve below the break-even wage. You can see that a wage above W star would result in negative profit because it would increase the size of the magenta area and decrease the size of the green area. Similarly, you can see that a wage below W star would increase profit above zero because it would decrease the size of the magenta area and increase the size of the green area. Once we realize that the labor demand curve is equal to part of the marginal revenue product of labor curve, we can also tell what will happen to that labor demand curve as output price changes. Output price appears in marginal revenue product because marginal revenue product is equal to marginal product times price. Thus, as price increases, the marginal revenue product curve shifts out, which also means that the labor demand curve shifts out. Similarly, as price falls, the marginal revenue product curve shifts in, as does the labor demand curve.